Welcome back to the Deep Dive. Today we are opening a file that I think many of us approach with a pretty heavy heart. We're looking at small cell lung cancer. And if you're a hematologist or an oncologist listening to this, you know exactly why the mood shifts when we talk about SCLC compared to its non-small cell counterpart.
It is the clinical definition of frustration. In the literature, you'll often see it described as the recalcitrant cancer.
That's the word.
And that word choice is deliberate. It really captures the stubborn, unyielding nature of the disease.
It really is the graveyard of drug development, isn't it?
Yeah.
I mean, we've spent the last 30 years watching these revolutions happen in non-small cell. You've got EGFR inhibitors, ALK, ROS1, KRAS now, while small cell has just remained this therapeutic orphan.
Yeah.
It's a disease defined by aggressive growth, incredibly early metastasis, and this distinct heartbreaking pattern we all see in the clinic.
You see this high initial response and then this almost inevitable rapid relapse.
Exactly. That's the paradox of small cell. You give platinum metapodin, maybe with a PD-L1 inhibitor now, like a tislelizumab or durvalumab, and the tumors just, they melt away.
They do. The response rates are 60, 70%. You feel like a hero for about 4 months.
For about 4 months, yeah.
But the biology of the disease just dictates that resistance sets in, and it sets in quickly, usually within 6 months. And historically, once that first line fails, we've basically hit a wall.
The therapeutic plateau, and until very recently, our options on that plateau were, well, they were bleak.
Yeah.
We had topotecan, which carries this reputation for significant toxicity.
Oh, it's rough. Myelosuppression, fatigue, alopecia.
Right, often for very, very modest gains.
Yeah.
Or we dusted off the old CAV regimen, cyclophosphamide, doxorubicin, vincristine, which honestly feels like practicing oncology from the 1990s.
And neither of those options was particularly appealing, especially for patients who are often elderly or have significant comorbidities to begin with.
Which brings us to the subject of today's deep dive. We're talking about lurbinectedin, known commercially as Zepzelca. But I want to be crystal clear right from the jump. We're not just doing a review of the package insert here. We've pulled a stack of literature. We're looking specifically at reviews from molecular cancer therapeutics and drugs in context, because we need to reframe how we think about this drug.
We absolutely do. There's a tendency to lump lurbinectedin in as just another chemotherapy agent, something similar to topotecan.
Right, another blunt instrument.
But when you actually look at the mechanism, that is fundamentally incorrect. This is a selective inhibitor of oncogenic transcription. It targets the very machinery that drives the small cell phenotype.
And that distinction between a general cytotoxic agent and a selective transcription inhibitor, that's really going to be the thread running through this entire discussion. We have a lot to cover.
We do.
We're going to break this down into 4 distinct acts. First, we are going deep, deep into the molecular biology. We need to understand this concept of transcription addiction and how this drug essentially hijacks the tumor's own engine.
Then we'll move to the neighborhood, the tumor microenvironment. We're going to look at how lurbinectedin remodels the immune landscape and how it can potentially turn these cold tumors hot, which, that has massive implications for future combination strategies.
Act 3 is a forensic audit of the clinical data. We are going to unpack the basket trial versus the Atlantis trial. We really need to explain why so-called failed phase 3 trial doesn't tell the whole story, and frankly, why the dosing strategy in Atlantis might have doomed it right from the start.
Yeah, that's a critical point. And finally, we'll ground all of this theory in practice. We've got some excellent case studies that illustrate the difficult decisions clinicians like you face every single day. Sequencing, managing toxicity in the elderly, and that big debate over platinum rechallenge versus moving to a non-platinum second line.
So let's start at the molecular level. Section 1, the Achilles heel. We keep seeing this term transcription addiction applied to small cell lung cancer. It sounds a bit like a buzzword, but biologically it describes a very, very specific vulnerability.
It does, and it's the perfect term for it. Think of a small cell lung cancer cell not just as a dividing cell, but as a factory running at 150% capacity, 24/7.
Okay.
These cells have almost universally lost their brakes. We're talking about TP53 and RB1, the classic tumor suppressors. They're inactivated in nearly all cases.
So there's no checkpoint. The foot is just slammed on the accelerator.
The foot is slammed on the accelerator, and the car is being driven relentlessly by these master transcription factors. The big players here, the ones you need to know, are ASCL1 and NeuroD1.
And these are the lineage drivers, right? They're what make a small cell in the first place.
Correct. They define that neuroendocrine identity. But here's the catch, and this is the addiction part. To maintain that identity and that insane rate of growth, the cell has to constantly read those genes. It needs to transcribe them into mRNA to make proteins at an absolutely frantic pace. It can't stop.
And from a structural biology standpoint, that creates a problem for the tumor, because to read a gene, you have to physically unspool it.
Exactly. The chromatin, which is just the packaging of the DNA around the promoters of these specific oncogenes, has to remain wide open. It's continuously accessible because the transcriptional machinery is constantly docking there, reading and moving on. The tumor literally cannot afford to pack that DNA away.
And that necessity, that open-door policy, creates a physical vulnerability.
It's the Achilles heel.
Enter lurbinectedin. Now,
Yeah.
chemically, this is a synthetic marine-derived alkaloid. It's an analog of trabectedin, which our sarcoma specialist listeners will know very well.
Yeah.
But lurbinectedin has a very specific mechanism of action.
It binds covalently to the minor groove of the DNA. But here's the key. It doesn't just bind anywhere. The molecule has a distinct preference for CG-rich triplets. We're talking about sequences like CGG, AGC, AGG, and TGG.
Okay, so we know it targets these specific triplets. But here's the thing I found fascinating in the Molecular Cancer Therapeutics review. It's not just about random binding probability. It's about where these triplets are located structurally in the genome.
Right. It's all about location, location, location. We're talking about the CPG islands, which are found within the promoters of protein-coding genes, but not just any genes.
Because of that open door state we just discussed.
Exactly. Because of that open chromatin state, the drug disproportionately finds and binds to the genes that are being transcribed at that frantic pace. So in small cell, that means the promoters for ASCL1 and URAD1 are essentially giant blinking targets.
So the drug slips into that minor groove in the DNA, forms a covalent bond, and creates an adduct. And this isn't just a roadblock, is it? It's not simply pausing the train on the tracks. It seems like it's derailing it in a very specific and very permanent way.
It's actually much worse than derailing. It's destruction of the engine itself.
Yeah.
So you have the RNA polymerase II, specifically the elongating form that is actively transcribing, zooming down the DNA track.
Okay.
It hits this lurbinectedin DNA adduct and it stalls. It physically cannot pass. But the cell doesn't just wait for it to clear. This stalling event triggers a very specific degradation pathway.
This is where the ubiquitin system comes in, right? The cell's garbage disposal.
Yes. The stalling triggers the ubiquitination of the RPB1 subunit of RNA polymerase lecectin. And as you know, ubiquitin is essentially a molecular trash tag. Once that tag is applied, the proteasome comes in and completely destroys the polymerase.
Wow. So you get this specific degradation of the very machine the cancer cell is addicted to using. You're not just pausing transcription, you're literally destroying the engine.
You're destroying the engine. It's an irreversible transcriptional arrest.
And the kicker, which I think is just brilliant from a drug design perspective, is that it spares pole first and pole 3.
Which is the crucial safety valve. Pole first and pole third are handling the housekeeping duties, making ribosomal RNA, tRNAs, the basic things any cell needs for metabolism.
Right.
If lurbinectedin wiped those out, the toxicity would be completely unmanageable for the patient. By specifically targeting pole third, it hits the protein-coding oncogenes, the drivers, while leaving the cell's basic life support systems relatively intact. It's incredibly elegant.
I want to touch on the subtypes briefly, because this is becoming a hotter and hotter topic in SCLC.
Yeah.
We used to think of small cell as just one homogeneous disease.
Right, just small cell.
But the literature now really divides it into 4 molecular subtypes. SCLCA, which is driven by ASCL1, SCLCN, driven by neurograda1, SCLC-DAFP, driven by POU2F3, and then SCLCI, the inflamed subtype.
And we're seeing this shift across all of oncology, right? Subtyping these monolithic diseases.
Absolutely. Now, the preclinical data showed something really interesting. In vitro, so in the Petri dish, the SCLCA subtype, which is the most common form by far, it actually looked less sensitive to lurbinectedin compared to, say, the POU2F3 subtype.
Which is counterintuitive if it's targeting the drivers.
Exactly. But when they moved to in vivo models, so patient-derived xenografts, which are much closer to a real tumor, the SCLCA tumors were incredibly sensitive, more so than the others. What explains that discrepancy?
I think that discrepancy is so important. It likely comes back to that core concept of transcription addiction in a living, breathing system. SCLCA tumors are, by definition, heavily reliant on ASCL1.
Right.
Lurbinectedin doesn't just kill the cell via DNA damage. It specifically downregulates the mRNA expression of ASCL1 itself. It turns off the very thing defining the disease.
Ah,
In a petri dish, you might miss that nuance of collapsing the entire transcriptional network. But in a PDX model, which better mimics what happens in a patient, the drug just pulls the rug out from under the SCLCA tumor's entire identity.
that is a perfect segue into the second layer of this mechanism. Because stalling transcription is one way to kill a cell, but we also have to talk about DNA damage. This is what you'd call the double hit.
Right. It's a two-pronged attack.
Hmm.
When you stall a replication fork or a transcription bubble, you create an enormous amount of stress on the DNA helix itself. This inevitably leads to DNA breaks.
Now, usually a cell has ways to fix this. We talk all the time about homologous recombination, the BRCA pathways, PRP inhibitors, but lurbinectedin plays a dirty trick on the repair machinery, doesn't it?
It does. It essentially sets a trap for a very specific pathway, the nucleotide excision repair pathway, or NER.
Okay, so NER. Normally, this is the mechanic that fixes bulky adducts on DNA. It sees a bump in the helix, like from platinum, it cuts it out and it patches the hole.
It's the cell's pothole repair crew.
Yeah.
But lurbinectedin binds in such a way that it completely confuses the mechanic.
How so?
It recruits the repair complex, specifically an endonuclease called ERCC5, which you might also know as XPG. XPG comes in to make the incision to start the process of removing the damage.
Okay.
But because of the unique structural distortion that lurbinectedin causes in the minor groove of the DNA, the repair process stalls right after the cut is made.
So the repair crew arrives, makes the incision cutting one of the DNA strands, but then it can't complete the patch. It's just stuck there.
Exactly. The drug tricks the cell's own repair machinery into creating a lethal single-strand break that rapidly converts into a double-strand break that it cannot fix. You are effectively turning the cell's own defense mechanism into a suicide weapon.
This leads to a really, really counterintuitive finding in the source material. I mean, usually with platinum therapy, we associate high levels of DNA repair capability with resistance.
Of course.
If a tumor is good at NER, it just fixes the platinum damage and keeps on growing.
Right. Enhanced NER is a classic, well-described mechanism of cisplatin resistance. But with lurbinectedin, the situation is completely reversed. Cells that are proficient in NER cells that have high levels of that XPG enzyme are actually more sensitive to the drug.
Because they have more of these repair crews available to come in, get tricked, and trigger that lethal cut.
Precisely. It turns the tumor's primary resistance mechanism against itself. And this is a fundamental concept for you as a clinician to grasp because it explains the lack of cross-resistance between platinum and lurbinectedin.
That's a huge concept.
It is. The very biological process that might make a patient's tumor resistant to carboplatin, that robust repair machinery, is the exact same process that makes them a perfect target for lurbinectedin.
So that completely justifies why we can even consider using this drug immediately after a patient has progressed on platinum. They aren't mutually exclusive.
Not at all. In fact, they may be synergistic in a sequential manner.
Okay, let's zoom out. We've been deep inside the nucleus. Let's look at the neighborhood. The tumor microenvironment, or TME. This is section 3.
And honestly, this is where I think the future of combination therapy lies. Historically, as we've said, SCLC is considered an immunologically cold tumor.
Meaning the immune system just doesn't see it. You get low MHC-I expression on the tumor cells, not a lot of T cells infiltrating the core.
Right, and that explains why checkpoint inhibitors alone drugs like nivolumab or pembrolizumab as monotherapy have had pretty disappointing results in relapsed small cell. The immune system just isn't showing up to the fight.
But the data we're looking at here suggests lurbinectedin completely changes the battlefield conditions.
It does, in two major ways. First, and maybe most importantly, we have to talk about macrophages. We often think of chemotherapy as just direct cytotoxicity to the tumor cell, right?
Yeah, kill the bad guy.
But lurbinectedin also acts as a powerful immunomodulator. It specifically and selectively depletes tumor-associated macrophages, or TAMs.
We should be specific here for our audience. These aren't the good guy macrophages. These are the M2 immunosuppressive monocytes that flood the TME, correct?
Yes, exactly. These TAMs are little factories producing cytokines that suppress T-cell activity, promote angiogenesis, and basically help the tumor hide and grow. They are the tumor's secret service and support network.
And lurbinectedin has a direct cytotoxic effect on these specific monocytes.
It does. It's selectively toxic to them. So by clearing them out, you are literally removing the immunosuppressive blanket that has been hiding the tumor from the immune system.
So you clear out the suppressors. What happens next?
Infiltration. By depleting the TAMs, you create a biological opening for the effector cells, the CD8 plus cytotoxic T cells and the NK cells, to actually get out of the bloodstream and enter the tumor core. You're opening the gates.
And the second mechanism involves the death of the cancer cell itself. You're saying it's not a quiet death.
No, it's very loud. It's a process called immunogenic cell death, or ICD. When lurbinectedin kills a cancer cell through that transcriptional arrest and DNA damage, it causes the release of DAMPs, damage-associated molecular patterns.
Things like calreticulin exposure on the cell surface or ATP release into the microenvironment.
Exactly. These are molecular eat-me signals and distress signals.
It's essentially the dying tumor cell ringing a giant dinner bell that tells the dendritic cells, hey, there's something over here worth paying attention to and attacking.
That's a perfect analogy. And the source material actually references a study where they measured this in patients' peripheral blood. They saw increased proliferation of circulating CD4 plus LEBA, CD8 plus WOW, and NK cells in patients who were being treated with lurbinectedin. They essentially turned a cold immune environment hot.
Which provides the perfect biological rationale for combining lurbinectedin with immunotherapy, even if the patient has already progressed on a PD-L1 inhibitor in the first line.
That's the whole theory.
You're changing the context. You're remodeling the TME so that the PD-L1 inhibitor can actually work again.
That's the hope, and we're seeing that played out in trials like LUPR, which we can definitely touch on later. But first, we really need to deal with the clinical data that got us here in the first place.
Let's move to Section 4, the clinical evidence. We've established the mechanism is incredibly elegant. But does it actually work in patients? It all starts with the Phase 2 basket trial. This was the study that formed the basis for the accelerated approval.
Right. This was a study of 105 patients with relapsed small cell. The headline number that everyone cites, the one you'll see in all the ads, is the overall response rate, ORR, of 35.2%.
Which we should absolutely contextualize that. Historical controls for topotecan, the old standard of care in this setting, usually hover somewhere around 16 to 24%. So 35% is a pretty significant step up.
It really is. The median duration of response was 5.3 months, and the median overall survival was 9.3 months. But you have to peel back the layers of that data. When you stratify by the chemotherapy-free interval, or CTFI, the picture gets much, much sharper.
Specifically looking at that platinum-sensitive cohort. So these are the patients who relapsed 90 days or more after their last dose of chemo.
In that group, the ORR jumps to 45%, and the median overall survival hits 11.9 months. I mean, those are very, very impressive numbers for a single-agent chemotherapy in the second-line setting for small cell.
That's almost a year.
It is. And even in the resistant group, so relapse in under 90 days, the response rate was still 22.2%, which is still active and comparable to topotecan, though obviously less robust.
Okay, so this all looks great, but now we have to address the elephant in the room, the Atlantis trial. This was the confirmatory Phase 3 randomized trial, and, well, it missed its primary endpoint of overall survival.
It did, and if you just read the abstract or the press release, you might be tempted to just write the drug off.
Of course, failed Phase 3.
And that would be a huge mistake. To understand Atlantis, you have to look at the trial design with a very critical eye. It was not a test of lurbinectedin monotherapy against a standard.
No, it was a combination. It compared lurbinectedin plus doxorubicin against the physician's choice of either topotecan or the SAAV regimen. Why on earth did they choose doxorubicin as a partner?
Well, there was some preclinical synergy data suggesting that an alkylator plus an intercalator would work well together. But clinically, it created a major toxicity problem. To make that combination tolerable to manage the myelosuppression, they had to lower the dose of lurbinectedin.
And this is the absolute critical point. In the basket trial, the one with the great results that got the drug approved, the dose was 3.2 mg/ml.
Right.
In Atlantis, they dropped it all the way down to 2.0 mg/ml.
That is nearly a 40% reduction in the dose of the active agent. And for what? To add doxorubicin, a drug that has never, ever been a superstar in relapsed small cell. So they effectively handicapped their star player from the get-go.
And when you look at the survival curves, it's interesting. They actually separate early on, favoring the lurbinectedin combo, but then they cross later on.
Which to me suggests that the lower 2.0 mg/ml dose of lurbinectedin just wasn't enough to maintain control over time. The efficacy wasn't durable at that dose. But there's another factor people miss. The control arm significantly overperformed historical benchmarks.
That's right. The patients receiving topotecan or CAV had an overall survival of roughly 7.6 months.
Historically, topotecan usually clocks in around 6 months, maybe 6.5. So lurbinectedin was fighting a taller opponent than expected, with one hand tied behind its back because of that dose reduction.
But the story doesn't end with the missed endpoint. There was a post hoc analysis that I think really redeems the molecule and clarifies the situation.
Yes, this is crucial. They basically did a synthetic comparison. They took the patients from the original basket trial, who received the full 3.2 millogene per unit dose of lurbinectedin monotherapy, and they matched them against the control arm of Atlantis.
So a proper dose to standard of care comparison.
As close as you can get without a head-to-head trial. And when you compare lurbinectedin monotherapy at the proper dose against topotecan IV, lurbinectedin was clearly superior.
Superior in efficacy.
Yes, across the board. The ORR was 41% for lurbinectedin versus 25.5% for topotecan. The overall survival was 10.2 months versus 7.6 months. But equally, if not more important for our listeners who are in the clinic, is the difference in the toxicity profile.
Let's really pull that apart. Topotecan versus lurbinectedin, side by side. Because efficacy is one thing, but if the patient spends their remaining months in the hospital with neutropenic fever, we haven't actually achieved much.
Topotecan is rough. I mean, we sometimes call it alopecia in a bottle, but the hematologic toxicity is the real issue. In that Atlantis control arm, you had grade 3 or 4 neutropenia in nearly 70% of patients.
70%.
Anemia in over 50%. Thrombocytopenia is very common. And the dosing schedule is a huge burden. It's a daily infusion for 5 days every 3 weeks.
That's a heavy, heavy lift for a patient who is already feeling poorly.
It is. Now compare that to lurbinectedin. It's a 1-hour infusion once every 3 weeks.
Okay.
The rates of severe neutropenia are significantly lower, around 40% in the pivotal trial. And importantly, the rate of febrile neutropenia is very low, around 5%.
Which means fewer hospitalizations.
Exactly. You don't mandatorily need prophylactic GCSF with lurbinectedin, whereas with topotecan, it's almost a requirement for many patients.
So for a patient population that is often frail, often elderly, and often beaten down by previous lines of therapy, that quality of life difference is just massive.
It's night and day. Patients feel better on lurbinectedin. They aren't in the infusion chair every single day for a week. They aren't giving themselves daily GCSF shots. That matters a lot.
This brings us squarely to Section 5, the strategic debate. We have the data, we have the toxicity profile, now we have to make a decision in the clinic.
The sequencing question. This is where the rubber meets the road.
This is it. You have a patient in front of you who relapsed 4 months after their last cisplatin dose. They are technically platinum sensitive by that classic 90-day definition.
Right.
The ESMO guidelines suggest re-challenge with platinum. The NCCN guidelines in the U.S. say maybe you can re-challenge if it's been more than 6 months, but you should also consider lurbinectedin, especially in that 3-6 month window. Who's right?
It's a really nuanced decision, and there's no single right answer. The platinum re-challenge dogma is based on a simple idea. If it worked once, it will probably work again.
And the response rates are decent, right? Around 49% in some series.
They are, but the toxicity is cumulative, and that's the part we can't forget.
We're talking about worsening neuropathy, ototoxicity, the renal issues. If you gave them cisplatin first line, giving it again just 4 months later is asking a tremendous amount of their bone marrow and their kidneys.
Exactly. And this is where the concept of preserving the platinum comes into play. If you use lurbinectedin in the second line, you're using a drug with a completely different mechanism and a completely different toxicity profile.
So it allows the patient's body to recover from the platinum's side effects, specifically that lingering neuropathy and the renal stress.
It does. And you aren't burning a bridge. That is a key argument I think clinicians need to consider.
You aren't. In fact, there's this fascinating resensitization hypothesis that we touched on earlier with the mechanism.
Right, the NER pathway.
Remember, lurbinectedin works best in NER-proficient cells. Platinum resistance is often driven by having a high level of NER proficiency.
So by using lurbinectedin in the second line, you might be selectively killing off the platinum-resistant clones. You're essentially clearing the field of the very cells that would have survived a platinum rechallenge anyway.
That is the theory. And there's actually some retrospective data that supports it. There was an analysis of patients who got lurbinectedin second line and then went on to get platinum in the third line.
And what did they find?
Their response to that third-line platinum was just as good, if not better, than historical controls of patients who had received it in the second line. The ORR was around 48%. MOS was nearly 16 months for that sequence.
So you extend the treatment runway, You get the benefit of lurbinectedin, you give the patient a break from platinum toxicity, and you still have the platinum card to play in the third line.
Precisely. Whereas if you go straight to platinum rechallenge in the second line, and the patient gets grade 3 neuropathy or their creatinine bumps, and they can't get any more, they might never be fit enough for a third line of anything.
You've essentially shortened their potential survival by playing your strongest card too early.
That is a very compelling argument for that sandwich approach. Platinum, then lurbinectedin, then platinum again.
I agree. For me, unless the relapse occurred very late, say more than a year later, where the biology has likely reset completely, I really lean toward using lurbinectedin in that 3 to 6 month window. It just keeps more options on the table.
I want to look at the future now.
Yeah.
Let's move to section 6, combination therapies. Because as good as a 35 or 45% response rate is for a single agent, we always want higher.
Of course. And the most exciting combination right now, in my opinion, is with irinotecan.
Another topoisomerase inhibitor. I have to admit, on the surface, that sounds a little redundant.
You would absolutely think so, but the mechanism is beautifully synergistic. So irinotecan's active metabolite SN38 inhibits topoisomerase I, preventing it from resealing the DNA nicks it creates.
Okay.
Lurbinectedin, as a separate action from its DNA binding, also traps topoisomerase I on the DNA. So they attack the same enzyme complex but in different ways, leading to this catastrophic accumulation of unrepairable DNA breaks.
So it's a pincer movement on the DNA repair machinery. What does the data look like?
The phase 3 expansion cohort data was really impressive. They showed an ORR of 62%.
62%.
Yes. That's approaching first-line efficacy numbers, but in a relapsed population. This is currently being validated in the Lagoon phase 3 trial, which is actually the designated confirmatory trial for full FDA approval of lurbinectedin. So that's the one to watch.
And what about immunotherapy? We spent all that time talking about the TME remodeling earlier.
Right, the cold to hot theory. Well, the Elabir trial combined lurbinectedin with pembrolizumab in relapsed patients. They saw an ORR of 46.4%. But the number that really stood out to me was the durability of those responses. Some patients had responses lasting over a year.
In relapsed small cell, a response duration of over a year is usually a fantasy.
It's almost unheard of. It really suggests that if you can use the lurbinectedin to break down that immune barrier, kill the TAMs, release the DAMPs, the pembrolizumab can then come in and establish durable long-term control. It's the first real clinical validation of that cold to hot theory we discussed.
Before we wrap things up, I really want to bring this all down to earth with some specific cases. The source material from Drugs in Context provided 4 really instructive case studies from both Europe and the US. These aren't just success stories. They illustrate the actual decision-making process.
These are great. Let's look at case 1. This is a 64-year-old male in Switzerland. A standard relapse after just over 3 months, so a CTFI of more than 90 days.
This is the classic gray zone patient, right? CTFI 3 months. But the guidelines could really go either way, platinum rechallenge or Lurby.
They chose lurbinectedin. He achieved a partial response that lasted for 10 months.
10 months in the second line. That is a huge win for that patient.
It's a massive win. And it was well tolerated, just some grade 2 fatigue. This case perfectly validates the use of lurbinectedin in that 3 to 6 month window where you might be hesitant to rechallenge with platinum due to that lingering toxicity from the first line.
Okay, case 2 was interesting because of the dose management. A 68-year-old male who relapsed after 6 months.
So a clearly platinum-sensitive patient by any definition. He started lurbinectedin but developed grade 3 neutropenia around cycle 5.
Now with topotecan, that might mean you have to stop therapy or you're flooding them with GCSF and it becomes a real management nightmare. What did they do here?
They simply dose reduced from 3.2 milligauge down to 2.6 milligauge bearer. They didn't even use GCSF. And the patient maintained his response.
For how long?
For over 14 months.
14 months on a reduced dose.
Yes. It shows that even at a slightly lower dose, and remember, 2.6 is still significantly higher than the failed 2.0 dose in Atlantis, the drug is highly active. And the toxicity is very easily managed without adding expensive growth factors. It shows the flexibility of the drug.
Case 3 perfectly illustrates that sequencing strategy we were debating. A 66-year-old female in the U.S.
Right.
She went chemo-IO first line, then lurbinectedin second line, where she had a response for 10 months. And then
she received platinum rechallenge in the third line. And here is the key takeaway. Because the lurbinectedin was so gentle on her system, she was physically and mentally fit enough to tolerate that third line platinum.
It perfectly proves the preserving the platinum strategy. If she had gotten Topotecan second line and developed severe fatigue or myelosuppression, she might have been too beaten up for any third line.
Exactly. The lurbinectedin acted as a crucial bridge, keeping the disease under control while preserving her organ function and performance status for the next line of therapy.
And finally, case 4. The elderly patient, a 79-year-old male.
This is a patient that, I think for many clinicians, you'd be terrified to put on Topotecan. The risk of sepsis and hospitalization in a 79-year-old with extensive stage small cell is just too high.
Absolutely.
But this gentleman received 22 cycles of lurbinectedin.
22 cycles. That's over a year and a half of treatment.
Over 16 months, yeah. He had stable disease. And for a 79-year-old with extensive stage SCLC, stable disease with a good quality of life is a home run. It confirms that age alone shouldn't be a barrier to this therapy. The safety profile allows you to treat patients you might otherwise have a difficult goals of care discussion with.
So bringing it all together, after going through the mechanism, the data, the controversy, the strategy, what's the synthesis here? What's the main takeaway?
The main takeaway is that lurbinectedin is not just a fallback drug. It is not Topotecan light. It is a targeted therapy that hits the core vulnerability, the transcription addiction of small cell lung cancer. And it offers a toxicity profile that is vastly superior to the old standards.
And from a strategic standpoint, it makes so much sense as a bridge between other therapies.
It acts as a bridge. It allows you to preserve platinum. It potentially resensitizes the tumor to platinum. And it may be the perfect partner for immunotherapy. It opens up the board and gives you more moves to make down the line.
We mentioned the Lagoon trial is ongoing. That will be the big one to watch in the near future.
That will be the definitive answer on the combination with UNO-Tecan. If that trial is positive, I think we will see a new standard of care for second-line treatment established very, very quickly.
Okay, I want to leave our listeners with a final provocative thought. We've spent decades, literally decades, treating SCLC based on the calendar. Platinum sensitive means relapse after 3 months. Resistant means before 3 months. It's all based on time.
It is an incredibly crude metric. It tells us absolutely nothing about the underlying biology of the specific tumor that we are treating in the patient in front of us.
So, based on everything we've discussed today, the transcription addiction, the immune microenvironment, the emerging data on subtypes, are we finally moving toward a biology-based treatment algorithm?
I think we have to. The future shouldn't be about the calendar. It should be about the phenotype. Is this tumor transcription addicted? Does it have high expression of a biomarker like SLFN11, which predicts sensitivity to DNA-damaging agents? Is it an immune-excluded subtype that needs TME remodeling?
So instead of asking how long has it been, we should be asking what is fundamentally driving this specific tumor?
Exactly. If we can validate these biomarkers, we could one day match the right patient to the right drug, whether that's lurbinectedin, a PRP inhibitor, or an immunotherapy combination from day one of their relapse. We aren't there yet, but lurbinectedin feels like the first real step away from the blunt instrument of general chemotherapy and toward truly understanding the unique biology of this recalcitrant disease.
Fascinating stuff. It really does feel like we are finally chipping away at the armor of small cell lung cancer.
It has taken 40 years, but yes, there is finally some light at the end of what's been a very long tunnel.
Thank you for walking us through all of that. And to our listeners, thanks for joining this deep dive into the Hematology and Oncology Toolkit. We will catch you on the next one.